I've described landfills a few times as a constant construction project, totally different than like an 80 facility that you build, you bring your waste to, it does its thing, it produces outputs. A landfill is something that is constantly being built and expanded over time, and this section should show you a little bit of how that happens in detail. So landfills have a complicated life cycle. It begins with finding a place where you'll actually be able to build a landfill, and there's all sorts of permitting and engineering studies involved with that. Then the site will need to be developed to make it ready to start bringing the waste in. So you'll, like I showed in my video with my little miniature, we'll need some buildings on site. We'll need to be ready for our landfill gas and leachate that we'll be collecting and potentially treating. And then when we actually start landfilling, we're going to need to get the cell ready before we put waste into it. But there's a whole practice of filling up the cell, and then we'll need to close the cell. And while all that's going on, we need to get ready to open the next cell so that we never have an interruption in operations. The waste never stops coming. So you keep going through this cycle of building new cells, filling them and closing them, and at the same time extending your leachate system and your landfill gas system so that you can manage all the gas and leachate from your growing landfill. And the core part of that landfilling operation is the actual placement of the waste. This is the bulk material that's building up the landfill. You can think of a landfill as, you know, you're building basically a tower of waste in a way that it's not going to fall over, and in a way that's going to let you put your leachate system and gas systems in. So it's planned at a high level how that's going to be done, and then from the kind of daily operations up to the longer term operations, it's all managed carefully. So the highest planning unit that you might talk about would be like the phase. That's just the big area of development. So you might have a landfill. Phase 1, we're going to develop this over this decade, and phase 2 is we're going to develop this part over this decade. The subunit of a phase is the cell, and the cell is something that you'd like physically go out and you'd get the engineering drawn for a specific part. So it'd have a little border. This is the cell, we're going to build it here, and cells are typically open for about 1 to 2 years. And the reason for that time limit is when the cell is open, before it's got its final cover system on, it's going to be liable to produce a lot more leachate than after the cell is closed. When it's open, any rain falling into the waste or surface water that manages its way in is going to flow through the waste and turn into leachate and have to be managed. So you want to do your cells in as small chunks as possible, so you have the least amount open to water getting into the system, but you don't want to be opening a new cell every week. That would just be impractical and expensive. So the sweet spot is around 1 to a couple years of these cells that are going to be filled. And once they're filled, then they're covered, and then you keep moving with your cells until your phase is full, and then you open a new phase. When we get more into the daily operations of the cell, so a lift refers to a layer, even layer spread across the cell, and it's going to take could be, you know, weeks or months to put a lift in, and each day they're going to be spreading the waste. Trucks are going to be showing up. Waste is going to be deposited, and then operators at the landfill are going to use dozers and compactors to add that daily material to the existing material. And so each day there's going to be a chunk that's added, which is called like a daily layer or a daily cell. And each day that chunk is going to be covered up to try and keep as much odor and leachate and gas controlled as possible. So let's look at all these in detail. So looking at phases and cells, this is a hypothetical landfill that's being built up over time. So on the very, very left, you can see it's a new site. There's these different phases numbered, 1, 2, 3, 4, 5, 6. And the little gray square that says working cell, that would be the cell of the landfill that's being filled at that point in time. So they've got their buildings close to the bottom, driving in up this access road, and then depositing waste in that working cell. So they'd be adding, you know, each day adding those daily cells or daily layers and building up the lifts until that whole cell is full. And it could be, they could be putting more cells on top of that cell. So I'll show you a 2D view of this in the next slide. But that's how you'd be going to one cell to fill it up. In the next picture over, phase 2, they've added cells all into phase 1, and then they've closed it off to stop that precipitation from getting into it, and they start filling up the next phase. And again, you'd work through that whole phase with little cells, each time extending the leachate collection system. And then when you're done then you can close the top of it. And you keep working your way all the way through. And then by the last one, you can see that most of the landfill has been closed and they're just filling in their last phase. And again, they'll do a bunch of cells until that phase is closed. And then they'll close off the whole thing. And then at that point, if they were still receiving waste, they need to expand and have a whole bunch of new phases ready to go that they would have had to start developing. They can even put new phases on top of the old phases. As we've mentioned, the waste compresses down over time, so you can free up airspace to put more waste in on that. But that's how this process would continue working over time. I'll show you the same thing in a 2D view so you can see what's going on, because you couldn't see the waste being built up over time. Again, we're building a tower of waste in landfill construction. So phase 1 and 2 are completed in this picture, and then they're working in phase 3. And you can see there's been, or the current cell, you can see the lift moving its way across, and they keep doing that and building it up to the current grade. And again, doing it in all a way that's engineered so that it's not going to fall apart while it's being built, and also engineered such that all the leachate is going into their leachate collection system in the bottom and not going out into the environment. And you can see in the closed phases, they've been temporarily capped, and they've got some gas extraction in. The reason it says temporarily capped is you'll often, before putting the final cover, put an interim final cover, just while it's really still active and settling a lot. And then you can do a really good job on the final cover, because if you do it right away, it's going to end up all over the place because of the rapid settlement. So there's an interim cover and then a final cover that goes on top of that. So you can imagine this whole thing kind of building up and over time, just like this, as the landfill is expanded and completed over time. And then on the daily, so like this little current cell, you can see kind of the layer building up across the phase. On the daily, there'd be the vehicles, so either the primary collection vehicles coming right off the curb if you're close, or secondary collection vehicles coming from a transfer station. They drive right up onto the landfill. And I showed you some of the different models. Some of them push the waste out with a walking floor. Some are actually tipped so that the waste falls out of them, gets stacked up for the operators, and then the operators will use dozers to move it around, and then compactors to press it into place to fit as much waste as possible into the allowable airspace. And in the picture, these little kind of parallelograms stacked together would be like a day's worth of waste. And each day that will be covered with a daily cover, and then it could be taken off before the next day. But that's kind of how it's built on a very small scale. And then this lift, 2 to 3 meters thick, will be built across the cell, and then a new one would be on top of that, et cetera, till the whole thing's full and you're ready to close off that section. On your day-to-day operations, it's important in order to maximize that geotechnical stability, to design, the angle and the thickness of that layer that's being compacted at a time. So these couple graphs on the side of the slide show you the effect of layer thickness. So the thicker the layer it is, the harder it is to compress that bit of waste at the bottom. So you want to minimize the amount of waste being compacted at a time. In this figure, they're showing the sweet spot to be at around 0.5 meter thick. And above that, it's really hard to compress the waste on the bottom. And then below that is the importance of the number of times compactors run over the waste. So they'll run over it while they're putting it on, and they can run across the slope, anything to pack as much waste in as possible. And the sweet spot highlighted on this figure here is 3 to 4 passes. More than that, you're going to have diminishing returns, but less than that, there's going to be a lot of air left in that waste. So very important for the daily operators to be tracking their construction so that they're following that plan for filling up the cell, and then doing it in a way where they're compacting the waste as much as possible to prolong the life of that landfill. And What they do in a lot of places these days is use things like GPS to be able to track the position of all the trucks, and then they can know exactly where things are getting filled and how much compaction is being achieved, and really optimize that operation from day to day, because that airspace is really, really valuable. Thinking back to that cycle of permitting the landfill and building it over time, it takes a lot of effort and investment to do this site approval and site infrastructure development. So in the next phase of actually landfilling, you want to milk as much productivity as possible so that you don't have to build new sites or expand sites, because that's really expensive and difficult to do.